Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the Lewis structures. In the previous lecture, we have done about the covalent bond and the octet rule, also the duplet rule. And you can easily find a video on the Lewis symbols in the playlist of the chemical bonding chapter on my YouTube channel. We are going to combine both the concepts, the Lewis symbols and the octet rule, to find out the structures of covalent compounds. Let me re-revise the octet rule. Every element wants to achieve the 8 electrons in its outermost shell, that is to attain the stable nearest noble gas configuration, except hydrogen, who wants to achieve 2 electrons in its outermost shell to achieve the nearest noble gas configuration of helium. So now let's come to the Lewis structures. In practicality, Lewis structures are of three types. The Lewis structures are of three types. The first one is the compounds, the covalent compounds. Covalent compounds having single bonds. Having single bonds between combining atoms. So the covalent compounds having single bonds between combining atoms, we are having its example to be F2, Cl2, Br2, I2, HCl, HBr, HF, HI, NH3, H2O, and many more. Now, let's talk about the second type. Covalent compounds having double bonds. Having double bonds between combining atoms. The examples are O2, C2H4, and many more. Now, the third type is covalent compounds having triple bonds between combining atoms. The example is N2, C2H2, HCN, and many more. Now let's draw the Lewis structures of all these compounds one by one. I'm starting with the very simplest one, H2. One more example, H2. The first example is H2. What's the atomic number of hydrogen? It's 1. So hydrogen will have 1 electron in its valence shell. This is the Lewis symbol of hydrogen. The another hydrogen will also have 1 electron in its valence shell. Now hydrogen wants to achieve only 2 electrons in its outermost shell. So here both the hydrogen will share 1 electron with each other to achieve the stable nearest noble gas configuration of helium. Now let's talk about the number of electrons for the first hydrogen. That's number 1 and that's number 2. That's for first hydrogen, and it has attained the stable noble gas configuration by having 2 electrons in its outermost shell. Now let's talk about the electrons of second hydrogen. That's the first electron of second hydrogen, and that's the second electron of second hydrogen. Now again, the second hydrogen has also achieved the stable noble gas configuration of helium. So that means H2 H2 molecule has achieved the stable noble gas configuration of helium. So that's the Lewis structure of H2, which is having only one bond. That's a single bond. Now, now let's talk about Cl2. I'm talking about the Cl2. What's the atomic number of chlorine? It's 17. What's the configuration of chlorine? It will be 2, 8, 7. That means chlorine is having 7 electron in its outermost shell. So the Lewis symbol will be chlorine 1, 2, 3, 4, 5, 6 and 7. Another chlorine will be 1, 2, 3, 4, 5, 6 and 7. Now, how much electron is required by chlorine to achieve the stable noble gas configuration of argon? It's only 1. So it will become 2, 8, 8, and that's the configuration of argon. So that means both chlorine atoms are going to share 1 electron with each other to achieve the stable noble gas configuration. So I'm making a bond. So this is the first covalent bond. Now after the sharing of electron, both the chlorine have achieved a stable noble gas configuration. So now let me count the electrons for the first chlorine. So that's number 1, number 2, number 3, 4, 5, 6, 7. Now it has shared 1 electron with second chlorine, so it comes out to be 8. So the first chlorine has achieved 8 electron in its outermost shell. Now let's talk about the second chlorine. Let me delete this thing first. Now let's talk about the second chlorine. Let's count the electrons. That's number 1, number 2, number 3, number 4, number 5, number 6, number 7 and finally the number 8, the 8th electron from first chlorine being shared with the second chlorine. So the second chlorine also achieved 8 electrons in its outermost shell. So the Lewis structure is formed between two chlorine atoms and a chlorine molecule is formed, that's Cl2. And again it's a single bond. Now let's talk about the NH3. My third example is NH3, that's ammonia. What's the atomic number of nitrogen? It's 7. The configuration will be 2, 5. What's the atomic number of hydrogen? That's to be 1, so its configuration be only 1. So now let's make the Lewis symbols of nitrogen and the 3 hydrogens. So that's my nitrogen, and nitrogen is having 5 electron in its outermost shell. So its structure will be, its Lewis symbol will be 1, 2, 3, 4 and the 5. Now let's talk about the hydrogen. That's first electron of the first hydrogen, the second hydrogen with the 1 electron and the third hydrogen with 1 electron. So it's bit obvious that hydrogen is going to share its electron with nitrogen to achieve stable noble gas configuration of helium by acquiring 2 electron in its outermost shell. So the bond will be like hydrogen got the 2 electrons in its outermost shell after sharing this. Now let's talk about the second hydrogen. Second hydrogen also got the 2 electrons in its outermost shell after sharing electron with nitrogen. And now let's talk about the third hydrogen. The third hydrogen also achieved 2 electrons in its outermost shell after sharing electron with nitrogen. So let's talk about the nitrogen. I'm counting the number of outermost electron after sharing electron with 3 hydrogen. So these are number 1, number 2, number 3, number 4, number 5, number 6, number 7 and the number 8. So nitrogen has also achieved 8 electrons in its outermost shell after sharing 3 electrons with 3 hydrogens. On the other hand, hydrogen also achieved 2 electrons in its outermost shell by sharing 1 electron each with nitrogen. Now that's the Lewis structure of the NH3 ammonia gas. Now let's talk about the H2O, the water. And you can also see that in the case of NH3 all bonds were single. Now I'm talking about the H2O. H2O. What's the atomic number of oxygen? It's 8. Configuration will come out to be 2, 6. Now let's talk about the hydrogen. What's the atomic number of hydrogen? It's 1, so configuration will be 1. Now I'm marking oxygen over here. How many valence electrons are there in oxygen? It's 6. So I'm marking 1, 2, 3, 4, 5 and the 6. Now let's talk about the hydrogen. That's a hydrogen, first hydrogen with 1 electron, and here's the second hydrogen with 1 electron again. Now it's understood thing that hydrogen will share 1 electron with oxygen to have duplet completed. So hydrogen has shared its 1 electron with oxygen. So now let's count the electron for the first hydrogen. It's 1 and it's 2. The duplet of first hydrogen is completed. Now let's talk about the second hydrogen. Second hydrogen has also shared 1 electron with the oxygen. Now the second hydrogen has also achieved 2 electron in its valence shell. That's number 1 and the number 2, and has achieved a stable noble gas configuration of helium. So that means both the hydrogen has satisfied their valences or duplet and have achieved a stable noble gas configuration. Now let's talk about the number of valence electron after sharing for oxygen. I'm counting the number of electrons of oxygen after sharing. That's number 1, number 2, number 3, number 4, number 5, number 6, number 7 and the 8th electron. So oxygen has also achieved 8 electrons in its outermost shell after sharing 2 electrons with 2 hydrogen atoms. On the other hand, hydrogen has also achieved the nearest noble gas configuration of helium by acquiring 2 electrons in its valence shell. Now that's the Lewis structure of H2O. Now let's make the Lewis structure of the covalent compound containing double bonds. Let me take an example of oxygen, the oxygen molecule. Now I'm drawing the Lewis structure of the compounds which will have double bonds in between them. Now let's talk about the first of all oxygen molecule. It's O2. What's the atomic number of oxygen? It comes out to be 8. The configuration will be 2, 6. So the Lewis symbol for oxygen will be 1, 2, 3, 4, 5 and the 6. Now let's make the another oxygen. The Lewis symbol of second oxygen will be 1, 2, 3, 4, 5 and the 6. Now by how much electron oxygen is short of the octet? Oxygen needs only 2 electron. It needs only 2 more electron to achieve the stable noble gas configuration of neon. So that means both the oxygen will share 2 electrons with each other because 6 are there in the outermost shell. So the both oxygens will share two electrons with each other. That means they will form the two covalent bonds. That's my first covalent bond. That's my second covalent bond. So now let's count the number of valence electron for the oxygen atom after first oxygen atom after the formation of two covalent bonds. My dear students, that's number first electron, the number second, the number third, fourth, fifth, sixth, seventh, eighth. Now you can see that the first oxygen has achieved 8 electron in its outermost shell by forming two covalent bonds with the another oxygen atom. Now, now let's talk about the number of outer electrons for the second oxygen atom after formation of two covalent bonds. Now, that's the first electron, the second electron, the third electron, the fourth electron, the fifth one, sixth one, seventh one, and the eighth one. So the second oxygen has also achieved 8 electrons in its outermost shell by sharing 2 electrons with the first oxygen atom, that is forming two covalent bonds with the first oxygen atom. So here you can see that there is the formation of two covalent bonds between two atoms, and that's called double bond, and that's called double bond. Now let's take some another example. We are taking another example to be C2H4. Now, what's the atomic number of carbon? It's 6, so configuration will be 2 comma 4. And what's the atomic number for hydrogen? It's 1, so configuration will be just 1. So here you can see that the carbon needs 4 more electrons to achieve stable noble gas configuration of neon, whereas hydrogen needs only 1 electron to achieve the stable noble gas configuration of helium, and that's for neon. So that means a 1 carbon will form 4 covalent bonds. Okay, let me draw the structure of C2H4. So that's my carbon. So carbon is having 4 valence electrons. It's number 1, number 2, number 3, number 4. We are having 2 carbons. Now carbon, that's number 1, number 2, number 3, and the number 4. How many hydrogens we are having? 4. Now always remember, in case of any hydrocarbons, hydrogen will never bond with another hydrogen. It will form bond only with oxygens and the carbon in case of any hydrocarbon or the organic compound. So I'm marking hydrogen to be here, the 1 electron, hydrogen to be here, second hydrogen is a 1 electron, there's a third hydrogen, 1 electron, and this is the fourth hydrogen, that's a 1 electron. Now hydrogen will satisfy its duplet, that is to achieve 2 electrons in its outermost shell by forming a covalent bond with the carbon. So that's my first covalent bond. Hydrogen got its duplet completed, number 1 and the number 2 electrons in the outermost shell, so the duplet of hydrogen is completed for the first hydrogen. Now let's talk about the second hydrogen. That's a covalent bond formation. So that means second hydrogen has also achieved 2 electrons in its outermost shell, the first electron and the second electron. Now let's talk about the next hydrogens. The third hydrogen. Third hydrogen has also formed a single bond with carbon, and you can see that the third hydrogen has also achieved 2 electrons, the 1 electron and the 2 electron in its outermost shell. So hydrogen has achieved a stable noble gas configuration of helium. So now let's talk about the fourth hydrogen. Fourth hydrogen, that's my covalent bond with carbon. So here hydrogen has also achieved 2 electrons in its outermost shell, the number first electron, the second electron. So hydrogen has achieved again the 2 electrons or duplets in its outermost shell. Now let's talk about the carbon. Carbon will form 4 covalent bonds to achieve the octet. Now let's talk about the first carbon. Here it has made only 2 bonds. Now that's our third covalent bond and the fourth covalent bond. So now let's count the number of outer electrons after sharing for carbon. So that's number first electron, second electron, third electron, fourth electron, fifth electron, sixth electron, seventh electron, and the eighth electron. So the first carbon has achieved 8 electrons by forming single bond with two hydrogens and double bond with another carbon. Now let's talk about the second carbon. I'm counting the valence electron for the second carbon after the formation of covalent bond. So that's number one electron, the number two electron, the number three electron, the fourth electron, the fifth electron, sixth electron, the seventh electron, and the eighth electron. So we got the 8 electrons in the outermost shell for the second carbon also. So the octet is complete for the second carbon also. So here we got the another example of the covalent compound containing double bond or forming double bond with each other. Now let's talk about the covalent compounds containing triple bond. For containing triple bond, I am taking the example of nitrogen gas, that's N2. Nitrogen was the atomic number of nitrogen, it's 7. So configuration will be 2, 5. The Lewis symbol for nitrogen will be, it's 1, 2, 3, 4, 5. Another nitrogen, 1, 2, 3, 4, and the 5. Now, how much electrons are required by nitrogen to achieve the stable noble gas configuration or to have 8 electrons in its outermost shell? It needs more 3 electrons to become 2, 8. So that means nitrogen will form 3 bonds. So here nitrogen will form 3 covalent bonds. That's the first covalent bond, the second covalent bond, and the third covalent bond. By forming 3 covalent bonds, nitrogen will achieve the 8 electron in its outermost shell. Let me count for you. The first electron, second electron, third electron, fourth electron, fifth electron, sixth one, seventh electron, and the eighth electron. So here you can see that nitrogen has achieved 8 electron in its outermost shell by forming 3 bonds or triple bond with another nitrogen. Now let's count the number of outermost electron for the second nitrogen after formation of triple bond. So that's my first electron, second electron, third electron, fourth one, fifth one, sixth, seventh, and the eighth. So the second nitrogen has also achieved 8 electron in its outermost shell. So that's the example of covalent compound having 3 covalent bonds or triple bond in between them or triple bond between the combining atoms. Now let me take another example of triple bond. We are taking the example of triple bond to be HCN. Now, hydrogen, its atomic number is 1, electronic configuration will be 1. Carbon, its atomic number is 6, configuration will be 2, 4. Nitrogen, its atomic number is 7, configuration is 2, 5. Now, let's make the Lewis symbol for hydrogen, carbon, and nitrogen. Hydrogen with 1 electron in its valence shell. Carbon with 4 electron in its valence shell. So it will be 1, 2, 3, 4. Now let's talk about the nitrogen. So nitrogen will have 5 electron in its valence shell. So it will be 1, 2, 3, 4, and the 5. Now let's make the covalent bonds. Hydrogen and carbon will form a single covalent bond. Here you can see that the two electrons has been achieved by hydrogen by forming a covalent bond with the carbon. So that's number 1 electron, that's number 2 electron. So now let's talk about the carbon and the nitrogen. Now carbon needs total of 4 electrons to achieve the octet, and nitrogen needs total of 3 electrons to achieve the octet. So that means carbon will form total of 4 bonds. One bond is formed with hydrogen, other 3 it will form with the nitrogen. And on the other hand, nitrogen needs only 3 electrons in its valence shell, so nitrogen will form 3 bonds. So that's the first covalent bond, the second covalent bond, and the third covalent bond. So now let's count the number of valence electron of carbon after the formation of 3 covalent bonds with nitrogen and 1 covalent bond with hydrogen. So that's number first electron, the second electron, the third electron, the fourth electron, and the fifth electron, sixth electron, seventh electron, and the eighth electron. So that means carbon has achieved the 8 electron in its valence shell by forming 1 covalent bond with hydrogen and 3 covalent bond with nitrogen. Now let's count the number of valence electron of nitrogen after forming 3 bonds with carbon. That's number 1, number 2, number 3, number 4, number 5, number 6, number 7, and the number 8. So that means nitrogen has also achieved 8 electrons in its valence shell after forming 3 bonds with carbon. And nitrogen has achieved the stable noble gas configuration of neon. Carbon has also achieved the stable noble gas configuration of neon. Hydrogen has achieved the stable noble gas configuration of helium. So I think that's enough for today. That's all for today. I hope you all understood today's lecture, and I hope that you will try more examples of these formation of covalent bond on your notebooks. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe, and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.